Do you have questions about change control, what it is and how it fits into a systems engineering environment? Well, change control avoids the following problem, where you go in, you change some software, change an interface, change a power supply spec, and then it breaks something else, but the other person designing this other part of the system, let's say the powertrain, doesn't know about your change, and when you finally integrate it, things don't work and people are surprised. So having good change control will help integration testing, it'll help you get your projects done a little more quickly. I've been very fortunate. I've had some good change control on these programs, but there was always a difference between the sandbox on our desktop where we'd experiment, we'd play with different things, and then the official baseline where we submitted our changes, and if they were approved by often a change control board, then they were incorporated. Recently had this experience with a requirements document. I was in charge of reviewing this requirement spec, and it was a little stale and it wasn't worded super well, but that's okay. Part of my job was to fix it up, and we got it. I had the meetings, but still it wasn't official. We had to put it through our change control board where we had some senior engineers look at it, some management, and they took a look and said, all right, well, did we take care of this? And turns out that prompted questions where we had to go back to the desk, add a few more things to make it complete, and then once we submitted it after making those changes, then it was incorporated into our program baseline, and then it became instructions for the engineers. These were the revised requirements, and they developed test plans and verification plans along with it. Now, this is very much a team play. Another benefit was people felt engaged, management wasn't blindsided, the chief engineer knew what was going on, and basically it brought people along to where this requirement spec would be well received and designed to, and people don't have the old version sitting on their desktop somewhere where they're making design decisions off of that. So change control keeps this process in check. It manages making changes so that people are aware and we're not surprising people. Because if we surprise our fellow engineers, when it comes time to integrate, it's going to be a lot harder to test and frankly a lot harder to even debug where the problem is. If you have questions on change control, I definitely recommend it. You don't want to introduce it too soon because then that constricts some engineering play. But if you're midstream in a program where you're starting the prototype or you're starting to write pre-production code, that's a good time to bring in at least change control, if not earlier, but at least by then, to where you're managing some of this chaos and risks, to where no one has any question about what is the baseline, but also there's trust and reassurance that people aren't changing it and others don't know. Comment below if you have any questions. You may be familiar with change control, but does your program have a solid configuration management system? And if it doesn't, do you want to know how to put one in and be able to sell it to management? Now, change control is managing the changes that are basically made against a controlled baseline, either the ground source of truth or your latest version, the agreed upon version by the engineers. Maybe you have a lead system engineer doing that. Changes against that need to be managed. So that's change control. But the system that manages it, that's a configuration management system. Basically, we're managing the configuration of the software build, of the product design, of the mechanical chassis. Let's say if you're building an automobile or maybe a gearing system. The system that manages what's the latest version, configuration management. That's extremely critical. Perhaps you've experienced it where people have versions of their documents on their personal hard drive, or worse yet, I was on a situation where we were doing some engineering releases. Okay, so we're stating the latest version of a drawing, and people make changes to the drawing. So what happened is it forked. So people made some changes on, let's say, an issue A, okay, and came up with what they thought was issue B, made some important changes over here, but then someone else had released issue B and then made additional changes on what was really their issue C. But this issue C over here did not have the other changes that were their issue B. Okay, well that sounds like alphabet soup. I could assure you it was that confusing. We were able to untangle it. Basically, we went through both threads, identified every change, and finally healed it up with making up letters here. It was issue D, as in Delta, to where that actually had everything. But we had to explain that there was different threads, and we finally we had to issue that issue C, then add these other changes in and to get to D. So it was wasted effort, a lot of meetings which didn't need to happen, and engineers are time and money, so you're wasting money on your project. So if you want to do two key things, one is set up a configuration management system. May not need to do it in the research and development phase early on, but pretty early on you want to consider this. And then you're going to use your change control to manage against that baseline. So let me know if you have any questions. Hopefully you're convinced of the importance of configuration management. An old boss who I'm tremendously fond of gave the piece of advice that once you've lost configuration management, you've basically lost the project. And I believe her. Comment below if you have experience in this, if you need any more questions, and I'll see you in the next step. Do you have questions on straight ahead record keeping compared to, say, configuration management or change control? Well, they're slightly different. And I had the experience with record keeping where it was really just as simple as keeping all of our memos, our records of decision. These are technical memos that talk to a systems engineering process. Keeping them in one place on a file system that we had set up at work. And then when we needed to go into component groups, thread owners for a software project, or maybe subsystem owner, then we could just give them the link to this particular memo where the systems lead, who later became the system manager, had made this decision on, it was a requirements verification traceability matrix, RVTM. We had decided on the attributes that we needed at a minimum in their RVTMs in order for systems to be able to do their job. This is things like verification method, location of the evidence, comment on why a particular method was chosen, requirement itself, and maybe we'd pull the parent of that requirement as well. So we'd all have it in one thing. The details of the matrix aren't important, but the fact that a decision was made and we stored the decision in a memo in a system that we could just find it with some trivial looking. If you don't experience that on your project, if you're always asking yourself, man, what didn't we make that decision last year, and where's the record of that meeting? I would invite you, consider just some basic record keeping software. Even if it's just setting up a repository where you have a folder called decision memos, another folder meeting minutes, just whatever it is, keeping that accessible, and then also doing backups of it. So we're keeping the records so we can track baselines. That's really going to help save some time. You don't want to pay engineers to be searching for that memo or what did they say at that meeting. If you can have that system, it's really going to save a lot of time. Having this RVTM memo really saved us because we're not bickering over what attributes to have. So if you have questions, comment below. If you want tips or suggestions, or if you're looking for a tool to do this, I can offer some suggestions. Other than that, if you have other questions about configuration control and configuration management as it ties into record keeping, let me know in the comments as well. Are you trying to deploy MBSE in your organization? Or are you trying to make the sale to management to put people and resources onto a MBSE sandbox project? Something that's a demo project or an exemplar of how MBSE might work for your larger program? Well, here are 3 questions I would lead with before starting in with the tool. And my experience has been, management, they're very busy. They don't necessarily want to hear how cool a new tool is, but they're very interested in return on investment, perhaps saving time. In fact, I had one manager come up to me, and after a demo that was funded, but there were 3 people working one aspect of the program, not the main design, but a different aspect of it. The manager came to me and said, hey, can we use this in our use case work? Well, it turns out we can. However, I did not lead with giving him a demo of a particular tool. Now, the 3 questions are: 1, is there some pain point involved? Is there rework? Are we behind schedule? Is there a gap between where we feel we should be? Like, well, gosh, we're halfway through, but we should have more project work completed by now. There's got to be some pain point to start with. If there's no problem, there's no problem, as they say. Now, the second question would be, is this pain point really a problem? I work on some very large programs, and it would be a tough case for me to sell, let's say, a full modeling tool for our maintenance profile, for instance. I'm making this up, but let's say we really know that well, we have the procedures down, the maintenance is viewed as being very efficient. There might not be a real problem there, and if there is, it's small, and we can use maybe some Lean Six Sigma techniques to do process improvement. That's different than, let's say, if we had to redesign a power supply 3 times, or somehow we came up with an expensive mechanical design to fit on a satellite payload, and somehow we got the envelope wrong. Now, that could be configuration management, and there are some other posts on that, but if there is a substantive problem that's costing us money or making us late, then we could lead with the third question and say, hey, well, how do we get here? And the real key question on the third part, to really finish it out, is what, if it had been in place, would have prevented this? They use this argument with configuration management, with project management, and they said, hey, if we had had project management in place from the beginning, we would have not had this maybe $2 million overrun on our cost. Again, just examples, but it's the same type of idea for MBSE. Because why would executive leadership in particular deploy MBSE? They would do it to be more competitive at the same time and have more money coming in and less money coming out. That's the language of leadership, and appropriately so. Management does need to make sure we finish on time, on budget, to compete in the marketplace. So ask these 3 questions if you're considering making a pitch for MBSE, if you need more resources or you feel it needs more attention. 1, what is the pain point? 2, is this pain point really a problem? Is this something people want to solve? And then 3, what, if it had been in place, would have prevented this pain point or would have helped us either solve it or would make the solution very easy or the risk much lower? Again, what process, what tool, if it had been there from the get-go, would have either prevented it or lowered the pain or queued up a very easy solution. So if you lead with that, basically it's the return on investment argument in a different form. But if you start with this, you'll at least convey to management that you speak their language. You understand what chafes them, what bugs them, and the problems they have to solve. And oh, by the way, we have a solution, deploying this tool. Now, finally, why is this so important for MBSE? It's because sometimes these tools have a very steep learning curve compared to, let's say, Doors Classic or even Microsoft Excel if you're managing requirements in Excel. Steep learning curve means upfront investment without a lot of return being experienced until 4 or 6 months down the road, sometimes a year down the road, to where we start seeing the benefits. Now, the good news is when we make that upfront investment, we will see the benefits, but it's more important than ever, particularly with MBSE and the complex tools involved, and also changing the way we do engineering business, to make that return on investment argument, to ask these 3 questions. And if you do, you'll be doing the right thing because you'll be helping your program save all sorts of time and money downstream. Morale will increase, you'll increase product quality, and we'll get all the benefits that we hear in the space by moving to a more model-based environment. Comment below if you have questions, if you want to talk more in depth, and let me know your feedback, and let me know if there's something about MBSE that you were able to persuade management on, and maybe a tip or technique you can share with the larger community. We can use all ideas here. Hello, and welcome to the next session. In this session, we're going to blend 2 different ideas, but it's really the same target. The target is, what is our goal? And as you remember, going way back into some of the very, very early sessions, we start out with a request from the customer. You'll recognize this drawing here. Request from the customer. Then we engage a group of people, resources to do engineering work. And then at the end, that goes in here, this is the product. Okay, with few exceptions, and the only thing I can think of is maybe offering a continuing service that might adapt. The systems engineering endeavor takes the request, does engineering work, and has the product. And you remember there are 4 different items in here. This is the technical. Won't go into too much detail here, but then there's the project management. This is the resources, facilities, something like that. And then this would be strictly like line management. Okay, and then they interact with each other like so. And then for systems engineering, this purview of systems engineering was the technical part of all the activities needed to go from request to product. So that's down here. And then you have, I'll abbreviate it to SE, systems engineers, for there. So this is our overall goal, what we're doing. And we talked a little bit about this in the last session about, okay, well, what's our purpose? And also we were reminded, that the stakes can be high. Some of us work on life safety systems, devices, from medical devices. It could be an airplane. We talked about the Boeing 737 MAX crashes recently. So if this is our goal, we need to fill in a little bit of the non-technical context. And by non-technical context, meaning what I'm really talking about is ethics. So now I know maybe in the past we thought of ethics as a separate endeavor. I mean, if we're in large organizations, we might have annual ethics training, it's all legitimate. But the takeaway here is that the ethics, it's not just something that we're mandated. This helps us achieve our prime directive, as it were, to borrow some Star Trek slang, but of taking a request and then yielding a product. Now, sometimes the marketplace determines how we're doing here. Sometimes if we have a government customer, there'll be a government body that decides whether we're doing this acceptably. But if the ethics part is not right here, then there are going to be consequences downstream that will prevent either us going from request to product on the current program, or it's going to affect our ability to do this on future programs, because either we'll be barred, or we won't be trusted, or somehow the marketplace is determined either we come in way too expensive, maybe we've done some spending that wasn't as tight as it needed to be, or the marketplace could say, hey, how they do business, the slave labor in various country, that's just not acceptable. Then you get into boycotts. Unfortunately, there are some very heinous work situations out there in the world. I don't mean to make light of any of that, but that could be a case where an ethical lapse, violating basic human rights. I know that's subject to interpretation. This is not a course on human rights, of course, but it makes a difference. The bottom line here is how it works, how we do things. It really does matter. So what does it mean by ethics here? I consider that the big three. Okay, so we'll just do this over here. Now you recognize some circles on the diagram. First of all, it's operating within the law. Okay, so we have to, the premise of this course, of this company, is we operate within the law. All right, so we'll just go put within. And that is radically different for different industries. Also, it's different for different countries. You know, I'm filming this in the U.S., but that does not mean that, you know, it's the laws are different in different countries, and it's whatever governs your current situation is what's in here. Again, they're not trying to be U.S. centric or anything like that, but whatever the code is, it's within the law, and that includes both, you know, criminal and civil statutes from the government, but also to our corporate policies. If our corporate policy says, hey, we have to do this way, this is how we do business, then that's in here too. We mentioned that a little earlier in the course, but that's what's within the law. The second is just safety. You know, we keep ourselves, our coworkers, safe. And I would propose this includes keeping the local environment safe as well. For instance, it's been a few years, but there was this massive explosion at a chemical plant in India. It's a well-known event, I believe it was in the 70s, where now all of a sudden the people around the plant were not safe because of these chemicals in the air. So that is a safety violation. So as we do our engineering, as we develop our line processes, as we spec out what chemicals we're going to use for cleaning, even as we're working maybe in facilities for our resources here, there are safety policies for how to handle compressed gases and highly toxic acids. So again, that's part of our going from request to product. So the safety is the second pillar. Then the third one, from an ethical point, is make a contribution. So we're going to put positive, a little positive sign, contribution. Okay, here's what this means in reality. If we have a program and let's say we've got our safety down, the safety's good, we're operating within the law, but and this is somewhat rare, but if for some reason we know our project will add no value, or somehow we're overspending to the point where we could easily do this for half the cost, for 98% of the scope, but somehow there's no easy way to change the negotiated price, and maybe we feel obligated to spend all the money. I would argue that maximizing this positive contribution is part of the ethical framework. Again, your own situation is different, but if we can make the case, resources, while plentiful, are still finite, it's our job. I would propose that we use resources wisely, and that includes consider process improvement at your facility, and if there's an easier way to do things, maybe we should consider it. Keeping safety and legality intact. I mean, you could always save money by ignoring safety and flouting the law in the short term. Longer term, you're putting at risk the ability to consistently get out a product given a request, in my opinion. But just some positive contribution there. It's got to move things forward. Again, as systems engineers, I would propose that we're here to make things better in the long run. This includes going after waste, fraud, and abuse, to use that phrase. So for our main goal of systems engineering, going back to our context of, we have a request, then we produce a product, we have activity and resources here. In the ethical framework, it needs to be within the law. There needs to be safety as a consideration. That is part of the mix. And then with these two settled, we need to focus on some positive contribution. Are we using resources wisely? Again, resources, while plentiful, are still finite. And then here, as a side, looking for waste, fraud, and abuse. We'll just call it WFA there. That, again, there are ethics specialists here that can go into more detail. Your organization probably has a ethics officer. I would suggest reaching out to him or her and see what their guidelines are. You know, especially if you're new and maybe we've just transferred in. You know, it doesn't have to be long. Maybe even just reading some of the ethics literature. Definitely do the ethics training every year. But I might encourage, probe down. What are the values of your company? That has to do with blending into the culture as well. But again, to summarize this one, to do our business, to meet our goal, ethics is a way that keeps this engine running. And that involves legality, being safe, and then focusing on some positive contribution. Why are we doing this project? And keeping an eye out for waste, fraud, and abuse. There's often a hotline that sometimes people can call. But it does have to be a phone call to the hotline. It could just be, hey, do we really need all this equipment? Are we under pressure to just buy for buying's sake? It could just be a very safe conversation. That's where it helps to have rapport. You may want to check out the session on neuro-linguistic programming for that. But these could just be simple conversations with coworkers. It doesn't have to be a big deal. Okay, this is an important session. Rewatch it if you need. We'll move on to the next one now, but please keep in mind this is our goal, and ethics blends into moving this goal. It's not just some separate entity. I'll see you in the next session. Now, there's a context here that we operate in, and you might ask yourself, why are we doing this? Why are we here? Okay, what's our purpose here? And I like to call this context, you can call it different things, but it's to deliver products and systems that will basically benefit humanity, will somehow move humanity forward. Let's take the invention of the airplane. Well, certainly you can make the case that it's moved humanity forward by enabling travel across long distances in reasonable times. Now, the other part of this is that when we make engineering decisions, when we do our work, our daily work, we need to keep this larger goal in mind. Ultimately, we're here to benefit. Now, this includes my own sector, which is military and defense. For systems, and if you're in that sector, there are systems that also add benefit to our national strategy. Whatever country you're in, there's some national defense strategy, and the products we work on there, they forward those interests too. That is certainly aligned with Integris systems engineering. But I'd like let's come up with 4 examples, and 2 of them really are kind of the same thing, but they're examples of where systems engineering could have avoided a lot of pain and suffering. And on some level, while there's lessons learned, while everyone's doing their best, there's some, instead of doing the wrong thing, there are examples where we could have brought our systems engineering to bear to avoid a lot of pain and suffering and ultimately loss of life. Now, again, hindsight is 20/20. I'll bring up just some common examples, but the main point isn't to judge the past. It's hard to make decisions real time sometimes, but it's to see how systems engineering can help and how it is very much a contribution, and that we're called to ethically and honorably bring our knowledge, our abilities to the world. That's why you're in this course. You want to improve your skills. There are other courses out there that are in the space where you maybe can get a little more technical, or maybe you can delve into some more project management specialty. There's subject-specific courses there. Personally, I'm a fan of earned value, so there's courses you can learn more there. But to bring our expertise to bear can really benefit, and you're going to see in these examples. We'll go early in time up to the present day. So many of us are familiar with the RMS Titanic. It was a large ship liner. It sank in 1912. There's several movies made about it, but if you look at the engineering of it, there were certain engineering concerns raised, and they had certain risks. They didn't call it that necessarily, but they had certain risks that would happen. They had a single wall hull. Will that save some money? Certainly saves a lot of steel. They might use iron back then, but there was some risk that if you hit an iceberg, it would be a puncture. There was no safety wall there, and it's always a trade-off. And again, we're not here to second guess the engineers. They're led by a company. Management makes these decisions. This is another reason why it's important management makes these decisions. So there are other things about the architecture of the ship. The bulkheads were only a certain level high. It could have 4 front compartments flooded, but not more than that. It didn't account into what's really a threat matrix, icebergs of a threat. It didn't account for a side glancing blow for a threat, which might open up more compartments. Again, this is not, of course, in the Titanic, but there's an example where the different engineering controls could have been in place, and they were discussed. If you look at the literature written about it. There also safety came up on the Titanic. Were there enough lifeboats? Well, there had never been such a well-publicized catastrophic accident, so they thought, well, we'll only have half the lifeboats we need, and no one really thought the ship could sink anyhow. So that, again, there are a lot of different issues. But it is a systems engineering issue because of systems engineering as a field brings in different aspects of a problem. The people aspect, safety. Are there enough lifeboats? If there had been enough lifeboats, it might have compensated for the fact that there were design flaws in the ship. Again, this is all in retrospect. So again, there are these balances. And then there was other operational procedures. Were there binoculars in the crow's nest? Had there been, then maybe they would have seen the iceberg earlier, and then operationally they could have turned the ship quicker. They would have started their turn more quickly, and then avoided catastrophe. But the point is that systems engineering involves looking at all these different aspects, giving them consideration. We can't give everything full resources to fix, but it's a way to maximize the safety and the contribution to humanity that we make by having a systems approach. And a systems approach, sometimes it's called a systems thinking approach, that's the craft of considering all the interfaces, how a product will be used. Even the Titanic, it's used by passengers sitting on the boat. For how would emergency procedures look, other aspects of the whole system, not only in development but in operation. So the other part of bringing up the Titanic is that sometimes the stakes are high, and there are some other incidents that you may remember. The space shuttle. There are 2 fatal space shuttle accidents. One was the Challenger in late January of 1986, and then the Columbia, again, is in mid-January. That was in 2003. And with the investigations that they saw, at least with the Challenger, there was a concern about the O-rings in the environment that was launched. Late January can be pretty cold in the U.S. state of Florida. Other than that, on a summer day, those O-rings are fine. The design is perfectly suitable given the risks. But it's that systems engineering looks at the risks, looks at the environment, and then moves engineering resources to mitigate risks to have the best system possible. No one has infinite time or money, but there's a way to maximize how we could have a product that contributes, here the space shuttle, and how we minimize downside risk like safety, loss of life. Space Shuttle Columbia had a similar thing with the tiles underneath. There's a lot of engineering work goes into there. I'd refer you to the reports. I like to go to the original NASA source. NASA is the National Aeronautical and Space Administration by the U.S. They administer the space shuttle. They've written about it. There's some congressional reports too. Dr. Feynman, it reminds me as being on that committee who wrote that report. Speaking of Dr. Feynman, if you look at one of the documentaries on the space shuttle, out there into space, Dr. Feynman put a O-ring into a glass of ice water, and then he took the O-ring out and then showed how brittle it was. And it was that brilliance in communications in his congressional testimony, and that's the point where people who are not of a scientific background, then they got it. Oh, this is the problem. This either should have been fixed, and it will be fixed, obviously, for future flights. And it was, even though he was one of the smartest individuals, smartest scientists, arguably in the world for decades, he went to his communications toolbox to communicate to his audience. It's one of the most brilliant examples of scientific communication out there. So I recommend looking that up, see if you can watch the video. But before then, it was just reports and papers and charts, and people couldn't feel, this is how the Challenger failed. Again, a similar thing with Columbia. They were problems. It was monitored as a risk, but somehow the risk wasn't high enough to the point where, this is actually what happens if there's a fissure in the undercarriage of the space shuttle during reentry. Finally, there's the example more recently of the two Boeing 737 MAX crashes. Now, much has been written about that as well. Others, for me, I would go to the Seattle Times or the IEEE, Institute of Electrical and Electronic Engineers. They've written about the crashes. It has to do with the guidance system and the inability of a pilot who's not very seasoned to realize, there's a problem with the guidance system, I have to turn it off in order to basically pull the plane up. The plane thought it was about to stall, so it kept going down. The pilot and the autopilot took over, so the actual human pilot couldn't right the plane. And obviously there's two tragic crashes, one in October of 2018 and the other March of 2019. Again, there's engineering there, but those are the stakes. The point is the stakes for what we do as systems engineering can be very high. It can be life and death. And Boeing is an excellent engineering company. They have people who try hard. They want to do the right thing. They're working through cost and schedule trade-offs as well. But it's the engineering expertise that we can bring to the table to steer these arguments. We might not make the final call, and at some point we've done our best. But doing our best means knowing systems engineering, bringing in a systems mindset so we see the big picture and can also be comfortable in the details sometimes. Bringing that systems mindset and then being able to work in organizational culture to the point where our opinions can be heard, where we can influence, and then our communication skills are top-notch to where we can convey the point, we can move audiences to our point of view, and then we'll discuss this in later this module. We come in with an ethical framework. So if we've done all this, then we've done our duty as systems engineers. And lives are being saved every day. We're never going to know about it because the engineering was brought to management's attention. Management wants to do the right thing in the big picture, and the right discussions are being held, and risks are mitigated. Now, this is a lot. We're going to delve into this more later in the module, but I wanted to at least share this as to give the reasons and kind of what is our goal for systems engineering. Why are we here? And also, what are the stakes? Sometimes they're quite high. Again, finish watching this module. You can jump to the next session. I'll see you there. I'll go back and watch this if you need. But please keep in mind, it's not just numbers. It's not just spreadsheets. We're contributing to humanity in some way. And honestly, it's up to us to bring our best selves for that. Not only get the skills, but also be able to communicate and then to bring that systems mindset so where we can at least know what needs to be brought up. Good job, and I will see you in the next session. Welcome back, everyone. And in this session, we're going to discuss things like attitude, things like our approach to our job. And I've put it near the end because we can go over the technical aspects of systems engineering, who we interact with, how we interact with resources, project management. We could discuss engineering operations. But there's something that's totally within our control that we can adjust if we need. And when we do, we're just going to find our career just goes a little further. And that's attitude, our approach, and something I like to call mindset. So we have a diagram up here where if we have the mindset up top, then we have approach on the lower right and attitude on the lower left. They all interplay with each other. Now, mindset is another way to say this might be our perspective. I like mindset a little better just because I think it covers more. but we could also call it our perspective. And what that is, it's just how we view the world. For instance, let's say someone cuts us off in traffic. Okay, well, we have several reactions. We could either snap out of it and realize, oh, I wasn't paying attention to the road. We could either curse this person and give various gestures, and I'll spare you those gestures. I'm sure you can imagine them. And then we could be angry for the next 5 minutes, and I'm trying to move toward this third one here, just because there's a lot of somehow there's a lot of people in a hurry on the roads where I live. I'm going to assume that that person must have some urgency where they have to weave in and out of traffic. Maybe they're taking their wife to the hospital to give birth, or maybe there's some injury, or they're about to lose their job if they're late one more time and they need to feed their family. But all of that is how we view what is the same event. Someone cut us off in traffic. Now we could take the same approach in our jobs. For instance, if we're given new tasking, some of you are probably transferred over from a different group into systems engineering. Okay, well, again, we could say, oh my goodness, maybe I better buckle down and learn some things about it. That hopefully it's why you're here. Second could be, work doesn't treat me right. These people don't know what they're doing. They can't resource a project. They need to read the PMBOK from front to back and then do it. That's what would solve all their problems. The third could be, hey, this is a real opportunity here. I have been doing R&D and been doing well there, but they would not have moved me over to this key systems engineering job for a product that has high visibility unless they had great confidence in my abilities, and who knows, maybe they're trying to diversify my experiences so they can promote me. Okay, again, that's an example of having 3 different mindsets and 3 different perceptions of just the same event. Oh, you got transferred over. In fact, you might have been on a project where 3 people were transferring in, or even 3 people were laid off. Now, being laid off is very serious. I'm not trying to make light of that, but one could say, you know what, I'll just have to start looking for other work. Second might be a lot of anger or resentment. Oh, these guys, I poured my soul out for 18 years. And the third could be, hey, this might be that opportunity to reconnect with my kids before they go off to college. I'll have a little time. My partner works, so maybe that's a workable option. And I could work on my novel or do some hobby activity. I've been working for 25 years, maybe a little break's okay. I had a friend that happened to. He had a year where he was laid off, and he reconnected with his kids. They were, I think, maybe 10 or 12 around that time. He played jazz saxophone. He was actually a serious musician in his youth. So he picked the saxophone back up, and he went to more Toastmasters meetings. That's actually how I met him. And sure enough, after a year, his old company picked him back up again. Okay, and I think it was a contractor, not an employee, but the salary was back, and he basically picked up right where he left off. So, he had a glow about him. He just had this glow, but that's mindset. He could have just been angry for a year and lost that year. So they're all connected, as you can imagine, because your mindset, it starts with this. That will drive at least in my own personal experience, that will drive our attitude. At least it drives my attitude. And then what my attitude is will drive my approach. Okay, and the approach out of here, okay, we have actions. Actions over there. Now, there are a lot of different models for this. Frankly, there are models out there that are far more elegant, but this just gives the basic idea that how we view the world, our approach, how we view random events as suspicious, or even just random people. Are they out to get us, or might they be here to help? Maybe they're just passing by looking for an extra donut in the break room. Those kind of rumors spread fast in the workplace. So, but I want to emphasize, though, for actions, if you're a level 1 manager or your team you're trying to influence, if I'm trying to change someone's actions, I try and enter here. As a matter of fact, that's worth a different color. I really try and enter in at the top. Because if I just get on someone for their approach, okay, hey, you're doing this wrong, you need to do it another way, that tends to bristle. What I need to do is, for change, I try and learn what is the person's mindset. Okay, what's their approach? How do they view the world? Then, if I want a certain action out here, I'll think to myself, hey, what approach would I need to have in order for them to do these actions naturally, for them to want to do them? And then for that approach, what attitude would they need? And then to get this attitude, what would their mindset have to be? Now in here you have something called emotional state. I don't want to go into that. There are other models again that are more developed, but we can put that as part of this here. So in here there's emotional state. Basically, I'm very much a believer in physiology. Is there an energy? Are they sort of up here in their head, and maybe there's some emotion there as well, maybe some anger? Or are they very, very calm? Is there not much emotion? Do they, when you're cut off, does your blood pressure rise? Your blood go to your extremities? Or is there a concern? Maybe the blood more stays inside. So again, out of scope for this course. However, it's there, it's present. I would encourage you to explore it. Some of it bumps up against the neurolinguistic programming. That's a bit more advanced. There's a mild overlap, but basically, mindset to me drives attitude. It also drives emotional state, and then that drives the approach, how someone approaches their life, and then from there the actions. So my recommendation is do not just try and go right to approach, or heaven forbid, try and just drive actions from change. That is, make this a different one here. I've just not found that to work. I have to go to the root. Even for myself, if I have a habit I want to change. For instance, I used to wake up a little later. I'd be on time for work, but I was not an early riser. I'd always wanted to be an early riser. So I had to look and say, hey, what's my mindset around all this? Because I tried setting the alarm earlier, and then it worked for a day or two, and it fizzled out for whatever valid reason. I had to go back to mindset and say, well, what's my perspective? And I had to realize, I perceive what I do in the late evenings to be very important, and I have goals in the day, and sometimes you got to work in the evening. And then I would combine that with, well, I need a decent amount of sleep to function the next day. So why don't I wake up maybe 6:30 in the morning, maybe 7, if I was able to work from home that day. And then I'll just get that extra sleep. Okay, well that basically prevented me from getting the action I wanted, which is, to wake up early and get some writing in, and maybe I wouldn't do email, but just kind of do some visioning for the day, before it gets noisy. So even for my own self, I have to go through this process. I can't just go here unless it's something tremendously simple. Usually I can resist that second piece of pie after dinner, but I go to mindset. What's my mindset? Also, from here, what hangs off is my why, my motivation. We'll put that up here. Okay, again, urge you to take notes, draw your own diagrams here. You'll be able to watch the videos later, but I try mindset, motivation. Another way to put that is, what's my why? Simon Sinek has a great book, Find Your Why. So that lives up here. Again, other models, but I think this one is simple enough to where get the main point across. What is that? We have actions, but the mindset drives the actions through this more circuitous approach. I think you'll find if you work on someone's mindset, ask questions, plant different ideas. Hey, what if we did this? Or is this really the approach? Is management really the enemy? Didn't they help you out the other time when you got into that trouble with that other department? I use that just as an example. Then, oh, well, maybe there. That now we can work on mindset before we go through, hey, I think your approach on this project is alienating one of the other teammates. You can't make fun of them because they root for a different sports team. Something, whatever it is. But anyhow, this is basically how attitude and approach drive our behavior. And as systems engineers, part of our job is to influence, and we have to know that what's going on here. All right, that wraps up this session. We'll go into a little bit more on identity, and we'll tie this a little tightly into a systems engineering career in the next sessions. But I need to lay this background so you knew what was going on, and you'll be able to use it in your workplace. I'll see you in the next session. Hello, and welcome to this session where we wrap up this module on understanding the big picture. And we've talked about quite a bit, and we'll put some of this on the board. But basically, this whole module has tried to tie in a lot of the more ephemeral concepts, the more fleeting concepts of not just systems engineering, but succeeding in the workplace in general. And this goes if you're management or staff, or if you're an entrepreneur, you have clients, or working in a large organization. Now, we talked about having our overall goal. Okay, what is the goal of systems engineering? Okay, basically taking something from request to product. This, you can almost say, why are we here? Why are we here in the first place? Okay, we have goals. Goals there. So we're here to do technical work, build a technical product or technical solution. But if you've come this far in the course, you've realized there's a lot more going on than just the technical activity, solving technical problems. Now, I also want to emphasize, particularly near the end of the course, we want to have an ethical foundation. So let me put that up here. I don't want to just call it ethics. It's more the foundation. This guides our decision making when the decisions are tough, because a lot of systems engineering is going back and forth between trade-offs, and a lot of times there are no clear solutions. We have to use our engineering judgment, our experience. We have to align also with corporate instruction. If my experience is that if it's a corporate rule, if it is a rule, there is a reason that rule is there. And it's usually some lesson learned, or just someone's experience, or for instance, if you work at a government shop or government contractor, a lot of times the government will levy rules that this is how we want business conducted. There are various motives and reasons for that, well beyond the scope of this course, but they're legitimate, and someone fought hard to put that rule there. So I want to emphasize the foundation for all that we do is it needs to be ethical. It's just more trouble than it's worth to not just have that base, that bedrock. Also, senior executive leadership is assuming we're doing all this anyhow, so we don't want to do things behind their back. The final bit that we talked about, probably more so in this module than the others, is just this, this mindset here. We have a positive attitude, just a little bit of optimism. This has to do with attitude that we had in a previous session. But it's that problem-solving approach. It can be solved. Colin Powell, a U.S. statesman and military figure, had as one of his sayings, one of his basic rules, I believe, was it can be done. That's what our employer wants. And honestly, sometimes, I've been in situations where I didn't know what the solution was. I did not know the how, but I did know the what. And then by the time I got to the problem that we needed to be solved, then a solution came. Either something came to me, or we had good collaboration on the team, and together we came up with something. So someone else piped in, maybe from a different field that had a different perspective. But all in all, it's this positive attitude that will really help not just our careers, but execute why we're here, to make this product. It's just going to help make a better product. Ethics, of course, is the foundation. And let's see, the one thing to leave you with is no one wants just to be told the long list of problems that the project faces. If you have a problem, if you can come in with 2 solutions and then have that conversation with your manager or project lead, they will very much appreciate it, because now the dialogue goes to, hey, what solution's better? Did you think of this? Did you think of that? Than just coming in and griping. Now, I'm all for letting a direct report vent. I'll give them 5 minutes and just they can say anything. It's off the record, and a lot of times they feel better and move on. So, notwithstanding, give some people time to vent, but I really like to come in with this positive attitude. It doesn't mean Pollyanna. So this is where the ethics come in. Okay, we're not so positive that we're hiding bad news and pretending to work when we know it won't. So this goes to the hope is not a strategy. Let me put this. Let's just say it's not an effective strategy. You can certainly have it as a strategy. Now, I'm all for having a healthy faith that people work hard and the project will succeed if we lay out a plan. But we need to at least have the plan. So let me put that up there. The other parts that we talked about in this module kind of fall under attitude. So I put positive attitude there, but this also includes what we had in a previous session. We have mindset. We have our approach. There's in here. There's problem solving. That's all over there. But there's the mindset, the approach, the personal choice, and how we show up. So all this, all this is in the space. So, but this. If we're trying to succeed in our projects, help our projects succeed in our own career, we can't just blend on the technical. I mean, we need to blend in other things. This is all going on in this space. We need to watch our mindset. Some would call this watching our state, our emotional state. Again, a lot of this is content I picked up from mentors, other places. You can message me if you want more specifics. But this of what we can choose, and just how we show up, our perspective. We can choose that. We can choose our perspective as well. So, again, the ethics, and then all toward why are we here. Again, you might remember going from the request originally from the paying customer. And then at the very end, we have our product at the end. So there's a lot of collaboration involved here. There's a lot of negotiation, a lot of interpersonal skills we need to bring to bear. There's a lot written on personal skills. I like the material on emotional intelligence, but I'll refer you to that. Definitely check it out. But as far as the flow goes, this covers a lot of it, and we can have a lot of fun with this too. It's engaging. I think you'll enjoy your time as a systems engineer because you touch so many different entities, and we need to bring our best selves. We need to interact with people. If interacting with people is not your thing, you may want to go to the system modeling side of systems engineering, where you're running code, you're writing code. But more and more, what field does not need a lot of interpersonal interaction? However, you're going to succeed at all that if you keep a lot of this in mind. We will do what we can, and just again comply with ethics, but then keep our main goal in mind. Now, there's a lot of collaboration there as well. The final note for some of this is something I like to call systems thinking. Now, systems thinking is this larger entity, and it's more an approach. If it lives anywhere, it might live over here, but we're here to realize systems, so it's here to, and then for ethics, again, another name for that, I like to put lessons learned. Honestly, a lot of the lessons learned I've had, one in particular, where we were working with this other institution, I could have used a little more systems thinking, where our decisions, let's say on requirement relief, will affect another person's product, even another institution's lane, and we need to be very careful in those negotiations. So, that particular situation worked out, but we had to make decisions that affected the larger community. And as engineers, as leaders, sometimes we have to, certainly. But that reminds me of the lessons learned. If these flow in ethics, then the overall piece, we can take a systems thinking approach. Good definition of systems thinking, the one I like is it's just a mindset that realizes all parts of an entity, or many parts of an entity, are interconnected, and that if I need to make changes or decisions, if I'm in a systems thinking mode, I'm putting my mind in the other person's shoes. Okay, if I make this requirement change, how would they view it? Or if I allocate $2 million for verification, how's project management going to feel about that? And if I keep that in mind, if I have that nature, that approach, if I can build that, then when I make decisions or proposals at meetings, for instance, now they resonate, and I can carry the day, and my ideas get accepted because I've taken the time to to think of the whole thing as a system. And the system could be something we develop. It could be the development system, where you have the people and the buildings and the teams. That's a system too. So this summarizes what we've talked about in this module, understanding the big picture. If you could put all this, look at the subsessions, the other sessions that speak to details on here, but this will give you a bigger picture there. So congratulations, this is the last session of the module. We're going to move to some brief conclusion sessions, and then you'll have completed the course. So I'll see you in the next module.